Day again, class. It's still Sir Capistrano, and this is actually the continuation of our Newton's law of motion. Wherein, in the past video, we already discussed Newton's law, kinematics, dynamics, some simplifications of Newton's law. We also provide a definition regarding forces and interactions, and we actually talked about some of common types of forces, and we introduce forces as a vector, and we have some illustrations regarding superpositions of forces, and by superposition of forces we actually conducted or we had computation regarding superposition of forces, and in that I think we are ready to formally discuss Newton's law of motion. So by Newton's law of motion, we actually have here three laws or three laws of motion that are introduced by Newton, right? So in that, let's move on to the first law. This is not a discussion that discusses the totality of Newton's law. It's more on some introductions or some illustrations regarding how Newton's law works. So, for the first law or Newton's first law, it states that a body acted by no net force moves with constant velocity and zero acceleration. So, this is actually a more familiar concept regarding Newton's law for you because, as you may have remembered, this is actually just related to our inertia or the tendency of an object or a body to remain motionless or at motion if there are no net forces acted upon it. So in here, kung if we are to say that in for I mean for Newton's first law, it just says that hangga't walang sufficient na force na didikta or magche-change ng direksyon ng ating object, what will happen is that our system or our body will remain in equilibrium, wherein by equilibrium, in a certain direction, in a certain in a constant velocity and zero acceleration. So ibig lang sabihin nito, if we consider the first law, kung patuloy-tuloy na nagmo-move ang isang object, if the object continues moving or continues being at rest, it just says that the summation of all forces or the superposition of all forces that are acting on the body is actually zero. So, ang ibig lang sabihin niyan, lahat nung mag-interact na forces sa isang object na may constant velocity ay actually zero. So in that, it just means that in consideration of our x components and y components of our forces, meaning to say all of uh, the summation of x components of our forces is also zero, and also the summation of all y components of our forces is actually at zero. Meaning to say, at this state, na kapag yung summation ng ating forces ay zero using our superposition of forces, and lahat ng y component ay zero din using the superposition of forces, this just means that our body is actually in equilibrium. By equilibrium, it just says that patuloy-tuloy siyang gumagalaw or patuloy siyang mag-remain at rest. Unless magdagdag tayo na force na maaring mag mag-introduce ng movement or basagin yung tendency natin na mag-remain in motion or constant velocity and zero acceleration. So, ang sabi dito, dun sa definition natin, constant velocity. Sir, paano mong sinasabi na at rest na under siya nun sa constant velocity natin? So, in some scenario, it can be a non-zero velocity, or at some cases, we will have here a velocity, or wag na, ano, we have here a Vx, which is actually equal to 0 meters per second or 0 kilometers per second. So, that is still constant. Okay? And if we have zero acceleration, meaning to say that 0 meters per second will not change. So, in that, I would like to introduce you to what we call inertial frames of reference. So, by inertial frames of reference, this inertial frames are actually a concept regarding kung paano mo titingnan yung isang moving body. And for this inertial range, kailangan mong magkaroon ng limits or kailangan mong maglagay ng limit kung saan ka ba magse-set nung ano mo, nung observation mo. Kasi for halimbawa, kung ikaw ay kung ikaw ay nag-o-observe sa may highway, ikaw ay nakaupo lang sa may waiting shed, ang ibig sabihin nun, ikaw ay nag-remain at rest. Pero para sa ikaw na isang observer na makikita mong may dumadaan na sasakyan, kung titingnan mo yung sasakyan, gumagalaw yung sasakyan. At kung merong tao ron sa loob ng sasakyan, nakikita mong gumagalaw yung tao sa loob ng sasakyan kasi gumagalaw din yung sasakyan. So, in that inertial frame or that reference frame, nakikita mo that that object is actually in motion. But if you look into yourself being a passenger, kumbaga ikaw yung mismo nandun sa loob ng sasakyan at ikaw yung magiging base ng movement or ikaw yung magiging basis ng movement or ikaw yung magiging reference ng movement at nandun ka sa loob ng sasakyan, nang gumagalaw ng sasakyan at nag-remain ka lang na nakaupo, alam mo na hindi ka gumagalaw din sa loob ng sasakyan. So that is how we will be looking into that frames of references. Ang ibig lang sabihin nito, andun ka sa reference ng observer mo. And we have here actually three examples of that frames of reference, and to be specific, inertial frames of reference. You may actually experience this when you are riding a vehicle. So, minsan, di ba, kapag nakasakay ka or sumakay ka sa isang sasakyan at nag-accelerate yung sasakyan, nararamdaman mo yung katawan mo na mag-move backward pag nag-accelerate siya. And pag nagpreno yung sasakyan, nararamdaman mo na parang yung katawan mo ay nag-move paharap. Alright? And that with it, that frames of reference, alam mo na may nangyayaring acceleration at hindi. So, in relation with our first law of motion, as you can see here, kapag ikaw ay halimbawa nagsuot ka nagsuot ka ng rollerblade sa loob ng isang empty na vehicle, and initially you remain at rest and the vehicle start to move. Ang pwedeng mangyari actually is your tendency to remain at the same position, as you may see here, pare-parehas pa rin yung position niya, pero gumalaw yung sasakyan. So, as you may notice here, since yung tendency mo ay nag-move ka, ikaw yung nag-move sa loob ng sasakyan. Actually, nag-move yung sasakyan around mo. Pero nag-accelerate siya, ang tendency mo ay mapunta ka sa likod. But kung titingnan mo yung frames of reference mo, hindi actually gumalaw, hindi ka actually gumalaw. Yung sasakyan yung gumalaw. Okay? So that is one of our inertial reference. And so is if you are moving forward in a vehicle and that kapag yung halimbawa at start, yung time zero mo, parehas kayo ng acceleration ng vehicle and ang naging tendency ay nag-slow down yung vehicle natin. As you may notice here, the acceleration is uh, on the back side of the vehicle. As you may notice, you will remain in motion even if nagbabago yung motion nung nasa paligid mo. And same with this, if you have a constant acceleration towards the forward, tapos biglang lumiko yung sasakyan, nafe-feel nyo to yung tendency na ah, mapupunta ka dun sa opposite side kung saan lumiko yung sasakyan. So kung lumiko yung sasakyan papunta sa kanan, ang tendency mo, since ikaw ay nag-build up ng inertia during the constant acceleration or constant velocity din nung iyong sasakyan, tapos biglang nagbago yung acceleration ng paliko, what will happen? So, ang tendency mo ay mag-fling ka papunta ron sa kabilang direksyon. Okay? And as you can see here, kung ang inertial frame natin ay nandun lang sa ating observer, hindi siya actually, relatively, hindi siya nag-change ng position dun sa vehicle. Okay? So, that is our inertial plane. Hindi ko na muna i-discuss or hindi ko na i-discuss yung computations regarding dito. But basically, that is our inertial frames of reference. Okay? So, in that, we have the second law. So, for the second law, if a net external force acts on a body, the body accelerates. The direction of acceleration is the same as the direction of the net force. The mass of the body times the acceleration of the body equals the net force vector. So, medyo may dalawa tayo, may isang bagay tayong pwedeng makuha dito. At isa sa mga bagay na pwede nating ma-derive using this definition or this law is actually the quantification of our net force vector. And that quantification of net force vector is this. We have their mass times acceleration. So in that, we will have this formula in which we will have here the relationship of mass and force, wherein mass, simulan natin din sa force or the summation of the net force is actually equal to mass times acceleration of the moving body, or it can be expressed as mass times the summation of uh, net force vector over acceleration, or syempre, acceleration is equal to force over mass. So that is our one of the main components or main na mga bagay na pwede nating makuha sa Newton's second law. And using that, pwede natin actually ma-quantify yung ating mass, yung ating acceleration, yung force, given na meron tayo nung kahit ano man sa kanilang dalawa. And also, dito na papasok yung ating amount ng net force natin, wherein our amount of net force actually gives an acceleration of 1 meter per second squared to a body with a mass of kilograms of, oh, the mass of 1 kilogram. So, meaning to say, yun nga, yung sinabi natin earlier kanina, ang 1 Newton is equal, or 1 Newton is actually equal to 1 kilogram times 1 meter per second square. Okay? So, in which, ayan, if you maintain a same net force, okay, anong mangyayari? At nagbabago yung mass mo. So, magiging proportional sila actually. So, if you have the same net force, for different objects bearing different masses, we can actually have this relationship wherein mass 2 over mass 1 is equal to acceleration of the first over the acceleration of the second. So as you can see here, uh, having a constant force or net force that is applied to an object, we can have here an inverse proportionality between the mass and acceleration of a body. Okay? So, try natin gamitin yan. Alright. So a horizontal force with a magnitude of 20 newtons was applied to a 40-kilogram box on a level floor with negligible friction. So what is the acceleration of the box? So we just need to use our formula. So as we stated earlier, shortcut na lang natin. Ano? So force is actually equal to mass times acceleration. Okay? So, using this formula class, kailangan lang nating i-retain ha or kailangan nating isipin lagi na dapat yung mass natin is in kilogram and yung force natin is in Newton. Okay? So, using first Newton's second law of motion, which is net force vector is equal to mass times acceleration, we can actually get the acceleration here wherein our acceleration will be equal to our net force vector over mass. So, this will be equal to 20 newtons divided by 40 kilograms. And that will be equal to our zero point 0.5 meters per second square. So, baka taka kayo, paano sir nakuha yung meters per second square? So, as you may have remembered, 20 newtons is just equal to uh, 1 kilogram multiplied to meters per second square. Okay? So, that is 20 kilogram meters per second square divided by 40 kilogram. The kilogram will cancel out. You will retain the meters per second, therefore, meters per second. Okay? I think I have here another example. So, we have this example. So, this is from, this is derived from an example in Young and Friedman, same with the other example earlier. So a ketchup bottle with a mass of 0.45 kilograms was pushed and released along a smooth and leveled surface. So as it was released, the bottle was moving at a velocity of 2.8 meters per second, then slowed down as it slid due to constant friction force exerted by the surface. It slid for 1 meter before coming to rest. So, what is the magnitude and direction of the friction force acting on an object? So, para lang mas makita natin ng mas okay, ano, or mas malinaw, so what we can do here is we just need to draw. Okay? So, ang sabi niya yung we have we have a ketchup bottle. Pangit. Mukha siyang ano, Erlen Mayer flask. With a mass of 0.45 kilograms. Also, ang sabi niya, it has an initial velocity which is equal to 2.8 meters per second. Okay? And the bottle moved. Siyempre, ito yung x natin, ano? From 0, so this will be our x naught to 1 meter. Okay, so this is 0 to 1 meter. So this 1 meter will be our x or our final position. So in here, we actually should also draw the the tawag dito, the diagram regarding the forces that are actually acting upon our bottle. So para dyan, gawa na lang tayo ng dot. So ito yung ano natin, representation natin ng bottle. As you may remember, we have there a normal force. And since yung bote natin ay nasa surface, it means it is actually interacting with the weight. Okay? And sabi niya may friction force. So friction force actually, we have here a friction force that opposes our the movement of the bottle. And we have here the applied force or the initial applied force. Pero para dito, pwede namang hindi nyo na muna isulat yung applied force. Okay? Pero at some cases, ayan, kailangan siya ilagay. So we can write that as FA. So in that, ang makikita nyo rito actually ay kina-counteract ng friction yung applied force. So pwede rin natin ilagay yan na wala. Okay? So basically, we have here a movement in we have a movement here with constant deceleration. So, kasi bakit siya constant deceleration or constant acceleration? We have here a constant friction force exerted by the surface. And also, we have initial velocity, initial position, final position. We also have mass. So in here, class, this actually will be a uh, formula or two-step na two-step na tawag dito, two-step process. Kasi as you may have remembered, according to the second law of motion, the summation of our forces is actually equal to mass times acceleration. And to be able to compute for that Fk or that frictional force, we need mass. So that mass is actually 0.45 kilograms, but we don't have our constant acceleration. Okay? And to do that, syempre, gagamit tayo ng mga formulas natin na ginamit natin for constant acceleration. And since we have here an initial velocity, and actually we also have here our final velocity, sabi niya kasi coming to rest. So, ibig sabihin, we will have here a 0 meters per second na Vx. Okay? So, to do this, what we can do is first compute for the acceleration. And to do that, we can actually use our equation 10 in our discussion, wherein our equation 10 is actually is our Vx squared is equal to our V naught x squared plus twice the acceleration multiplied to our displacement, which is actually x minus x naught. This is just 1. And we just need to get this acceleration. So what will happen is we just need to transpose, and we will have here 2a times our displacement is equal to our vx squared minus our v naught squared. So divide this both by the displacement and the 2. So we will have your acceleration will be equal to vx squared minus v naught x squared over our 2 times x minus x naught. Okay? So that will be our acceleration, and using this, the given, so we have a vx which is 0, right? Minus our initial velocity, which is 2.8 meters per second. You need to square that over 2 times x, which is 1 minus 0 times 1. So, in here, upon computation, our acceleration will actually be equal to negative 3.9 meters per second square. But as for the force, we will actually treat this as a positive number. Bakit? Kasi that negative 3.9 meters per second is actually with the same direction of our force, which is towards the left. Okay? So, mangyayari dito, our summation of what will happen here is our summation of fx, para lang, kasi fx lang naman yung movement natin eh. Wala naman tayong fy. Will actually be equal to our negative force, which is actually equal to our max. Alright? So, we will have, which is actually equal to our 0.45 kilograms times our negative 3.9 meters per second square. So, we will have here a negative F, which is actually equal to uh, negative 1.18 kilograms meter per second square, which is actually equal to negative 1.8 Newton. So, that will be our magnitude, and as for the direction, it is moving to the left kasi negative yung ating friction. But if we consider the force or the movement of the force as the positive direction, syempre, our friction will be 1.8 newtons uh, instead of negative 1.8. Okay? So, upon the direction of our friction, positive yung ating force. Pero kapag ang titingnan natin ay yung direction ng movement ng bottle, our frictional force will be negative. Okay? So that is the application of our second law of motion. And as you can see here, medyo nagiging mahirap yung mga bagay-bagay. But before we continue on our discussion regarding the third law of motion, let's first quantify or discuss the difference between the mass and weight. Ayun, and sabi natin kanina, weight is actually a force. And based on our discussion in chemistry, mass is actually an intrinsic property of an object. By intrinsic property, kahit anong mangyari, hindi siya affected ng mga external na bagay. Kung yung mass ay nare-retain kahit na nasaan siya. Okay? So, hindi siya affected nung tinatawag nating external concepts. And by that, uh, mass is actually what we call an inertial property of the body. Okay? So, mass is an inertial property. By inertial property, ayun, that mass is actually affected by forces or that it actually quantifies the forces. So, in general, mass is what keeps the object at rest if you try to apply a certain motion into it or a certain force. And by weight, weight is actually a force wherein weight is mass times the gravity. Ibig sabihin, yung weight natin, it can actually change. So, halimbawa, kung nandito ka sa Earth, iba yung magiging weight mo kapag pumunta ka sa Mars. Pero if we are talking about mass, if you have a mass of 51 kilograms here in Earth, kapag pumunta ka ng Moon or ng Mars, magbabago yun. Ano? Hindi yun, mare-retain yung mass mo. Hindi siya magbabago. So, yun lang yung misconception natin sa mass and weight na kailangan nating tanggalin. If you are talking about mass, it is the inertial property of the body. Meaning to say, uh, hindi siya nagbabago depending sa environment niya. Not unlike our weight, which is actually a force, wherein weight is actually equal to our mass times the acceleration due to gravity. And, ayun, so magbabago siya. So meaning to say, for 1 kilogram of mass, it has actually a force or a weight that is equal to 9.8 newtons. So bakit ko nasabi yun? Kasi if we have 1 kilogram and we get for the weight, so weight will be, we just multiply that to our 9.8 meters per second square. Yun kasi we will have here 9.8 kilograms meter second square. Okay? So that means we will have there 9.8 newtons per 1 kilogram mass. Okay? So that is the difference between the mass and the weight. Okay? So for the last one, we have here our third law. So for our third law, if a body A exerts force to a body B, then a body B will exert a force on body A. So these two forces have the same magnitude but are opposite in direction. So two forces act on different bodies. So in here, kung sasabihin lang natin or kung titingnan natin siya in hindsight, halimbawa, ikaw ay pumalo ka or pinalo mo yung bola ng volleyball or kumbaga nag-spike ka, ganyan. So, that amount of force that you applied to the ball is actually equal to the same force that the ball applies to you. So, kung gaano mo kalakas hinampas yung bola ng volleyball, ganun din yung force na babalik sa'yo. Same goes kapag ikaw ay isang halimbawa, ate, magulang, nanay, or tatay, na pinalo mo yung isang bata. Okay, so if you, pag pinalo mo yung isang bata, the same force will actually be returned to you. So, kumbaga, ganun lang din kapag nag-push ka ng isang object. If you push a certain object, that object will actually exert the same force to you, lalo na kung hindi pa gumagalaw yung object. Pero actually, kahit gumagalaw na yung object, the same force that you, the you will be still exerting force towards that object, and that object will still be exerting force onto you. So, ganun yung sinasabi natin sa Newton's third law of motion, or yung sinasabi natin for every action, there is actually an equivalent and an opposite reaction. Okay? So, paano ba natin ipapakita to? Or paano ba natin ipapakita yung Newton's third law? So, kumbaga, let's say you run out of fuel for your vehicle. For you vehicle yan. That's for your vehicle. And you decided to push it to the nearest gasoline station. So, while your vehicle is starting to move, how does the force you exert on the vehicle compare to the force the vehicle exert to you? So at first, makikita natin or mapapansin nyo, kapag nagsimula kang itulak yung vehicle mo, lalo na kung mabigat yung sasakyan, you will be exerting a lot of force towards the vehicle. And at the same time, that vehicle is actually pushing the same amount of force onto you. So, for both cases, actually, how do these forces compare when you are pushing the vehicle along a constant speed? So, ganun lang din. Kahit na nararamdaman mo na parang hindi na nagpo-push backward sa'yo yung vehicle, it is actually pushing. It is actually exerting force onto you even if it is moving. So, mga pa at rest man or near rest or constant or cruising speed na yung push natin, uh, the vehicle will still be pushing onto us. Okay? So, yun yung tinatawag natin magkakaroon na tayo ng action-reaction pair na kahit anong push mo, so, kumbaga, ito yung car, you push the car, nag-move siya, but ang mangyayari, magpupush pa rin pabalik sa yung car. So, force you to car and gawin nating arrow. Gawin nating man, or not man, person to vehicle, and we will still be encountering a force from the vehicle towards the person. So, ganun yung mangyayari dun sa ating action-reaction pair. Kahit na gumagalaw na, gumagalaw na yung sasakyan natin, or meron na siya, nag-accelerating na siya, or it is accelerating, uh, it will be still pushing or exerting the same force that you are applying into it. Okay? So that is also true for what we call the tablecloth trick. Yung iba isipin sa inyo, di ba sir, inertia lang yan? But actually, that is true. And at the same time, meron pang ibang matters na pwedeng tayong tinitingnan. So, kumbaga, for this one, hindi natin actually titingnan yung force na ine-exert nung gumawa nung trick dun sa cloth. But what we can look into this, or pwede nating tingnan dito, ano siya, is yung mga objects natin. So we have there a china, we have there a vase, we have there the table. So as you can see here, kung titingnan natin actually yung vase, alam natin na merong exertion or nag-exert ng force yung vase towards dun sa table. So that is force of the vase towards the table. Also, we know that the table will also be pushing. Tama ba? So, anong direksyon yung magiging push nung or exertion nung lipat natin yung arrow para mas malinaw. Okay. So, in this scenario, if we have that vase will actually be exerting force towards the table. And also, the table will also be exerting a force towards the vase. And that force is actually uh, equal to each other, same magnitude, but we will have opposite direction. Okay? And that force actually retains yung nare-retain yung force na yan. Nagkaroon lang tayo ng slight na movement dahil gawa ng movement mismo ng cloth which is actually moving towards there. But as you can see here, mare-retain yung action-reaction pair natin. And also, ano pa ba yung ibang forces na pwede nating makita bukod doon sa movement nung or doon sa action-reaction pair na to? Meron actually pa tayong isa pang action-reaction pair dito, which is actually our long-range action-reaction. So, that is actually the force that is applied by yung gamitin natin itong isa pang base na to towards that force that is applied by the earth to the vase. Okay? And as you may see here, since merong ganyang reaction, pwede rin mo ring i-expect that we will having action-reaction pair wherein we will have here a force that is applied by the vase towards the earth. Okay? So we have here two reaction pairs in there. So as you may notice here, we actually have these two action-reaction pairs na pwede nating makita. And once na ni-remove na natin yung table, syempre, mawawala yung isa. Kasi hindi tayo pwedeng magkaroon ng iba pang reaction, uh, action-reaction pairs natin. So basically, these are the action-reaction pairs of the base and the table and the base and the earth. Okay? So, pwede siyang yung ano natin, yung Newton's law or yung tinatawag nating third law Newton's third law will actually be a contact action-reaction pair and also long range contact reaction long range action-reaction pair. Okay? So, those are our action-reaction pairs. So, also, we also have here another contact reaction pair. So, we have here our a stonemason that drags a marble block across a floor, pulling a rope attached to the block, and the block is not necessarily in equilibrium. How are the various forces related, and what are the action-reaction pairs? So, ito yung magiging itsura ng ating setup dyan. So, meron kang isang stonemason na hinihilang isang marble block across the floor. So, we have their surface, we have their the tension force, we have their yung force na ina-apply nung stonemason and yung force na ina-apply nung block. So, as you can see here, there's a lot of force that can be studied here. But in the same sense, these are the reaction pairs na pwede nating makita dyan. So, our first reaction pair then here is the force that is exerted by the rope to the man and force reacted by the stonemason on the rope. We also have there the force that is acted upon by the brick or exerted by the brick on the rope. And we also have there the force that is exerted by the rope on the brick. So, regarding here, dahil kasi class, pwede actually tayo ditong magkaroon ng hindi reaction pair. This is not an action-reaction pair. Why? Because as you can see here, we actually have here three bodies na pwede nating tingnan. So, ito yung body A natin, yung brick, body B, yung C, and body C, yung stonemason. So, kaya hindi sila action-reaction pair kasi yung action-reaction pair na nangyayari dito ay actually nangyayari yan dyan sa rope pero not necessarily on the stone or the marble block and our stonemason. So, and at some cases, we have here this illustration na sinasabi lang dito, hindi kasi necessarily equal yung force no na-apply ni nung rope dun sa brick dun sa force na ina-apply nung man dun sa rope. So mangyayari lang 'yan or magkakaroon lang tayo ng action-reaction pair na uh, magiging action-reaction pair itong force nung block dun sa rope at yung force nung man dun sa rope kapag sinabi natin na yung mass ng ating rope is actually zero or ititreat natin siya as massless. Pero pag sinabi natin hindi massless yung rope, hindi natin pwedeng i-consider na action-reaction pair yung force na applied nung brick sa rope at yung force na applied nung man dun sa rope. Okay? Because the force of the rope that is applied to the block is not actually equal or not always equal to the force applied by the man on the rope. Okay? So that is our illustration or another illustration of our third law of motion. So in that, we will be actually finishing our discussion here. And to sum it up, we have here this properties of or distinctions or concepts regarding Newton's law of motion or forces, wherein we have here force is a vector. Therefore, we can apply vector addition, vector multiplication, and the like on our forces. And according to first law, no net force means constant velocity and zero acceleration. Inertial property of body is characterized by its mass due to our second law of motion. And we have weight is not mass. Weight can be equal to mass, but not necessarily mass is weight, okay? Or weight is mass. And two interacting bodies exert opposite forces to each other with equal magnitudes based on our third law. And on the simplification of our Newton's law, for the first law, a body will remain at rest or in motion unless it is acted upon by a force. And the second law of motion states that a body is acted upon by a net force and it will accelerate or decelerate. And for the third law, for every action, there is an equal and opposite reaction. Nakalimutan ko yung and opposite reaction. Okay? So, we have those three Newton's laws. And next time, we will be talking about free body diagram. Uh, but before that, let me just say that this will be the end of the coverage of our midterms examination. And just like any other subjects or any other just like any other of our just like our other classes, I will still be giving you discussions regarding our subjects or this subject, but those concepts will not be included in our midterm examination. So in that, have a good one. Bye bye.